Okay, everyone, we're going to be going over the first skill today, which is angular and tangential acceleration. So first, we're going to go over some beginning kind of like an overview of some of the concepts, and then we'll go into some examples. But little things that we need to know. First hour, you did this yesterday a little bit, but just kind of important pieces that we need to know. How many degrees are in a full circle? That would be, drum roll, 360 degrees around an entire circle, right? That would be the angle, theta. Okay, how many radians are in a full circle? That would be now the exact same thing, but in radians. That is 2 pi is one full revolution around the circle. Radians. What do you call how fast, or sorry, how far something moves? And that would be just translational. And we'll get into what translational means here in a second, but translational displacement, right? That's when we're talking about how far something moves from its initial point to the final point. And when we talk about how far it moves in a straight line, that is translational displacement. But what do you call how far something moves in a circle? Like maybe something goes from 0 and then it rotates to up here, and we have that angle right there, right? Well, that angle is what we call an angular displacement. So rather than just talk about the straight line that it moved, we talk about how much this thing rotated. And that usually we measure in radians. It's a bit more convenient to talk about those quantities in radians. And then talking about quickly, what do you call how quickly something moves in a certain straight direction? Well, that would be like we talked about before. Translational means straight, linear, right? So this would be translational velocity. And so now when something moves between 2 points, we talk about how quickly it does that. So now we bring time into part of this quantity, right? And if we want to talk about how quickly something rotates, hopefully we're catching the pattern, this would be angular velocity. And angular velocity just talks about now how quickly something rotates, whereas translational velocity would be in meters over seconds, right? Don't mind that. Angular velocity, if we usually measure angular displacement in radians, once we bring time into it, this would be measured in radians per second. So these are all quantities we've talked about before, and just some kind of common terms that people get kind of mixed up, right? Translational and tangential all just mean linear. So an easy way to remember this, a tangent line is a straight line. So anytime you see something called tangential, it just means something going in a straight linear fashion. Okay. Angular and rotational are sometimes used interchangeably, and angular and rotational both mean the same thing. So I could have angular velocity or I could have rotational velocity. They mean the exact same thing. It really just depends, who's writing the problems that you're doing. Okay, getting into some of the variables. So here we have displacement, and this would be the more traditional displacement that we've been using, kind of the when we're talking about going in a straight line. Angular displacement, remember this is the change in position. This is now the change between angles. So this is what we talked about if I have something that is actually rotating. So something that goes from one point to another point. So this would be its initial angle. This would be its final angular position. That change in angle right there would be the angular displacement. Okay. The velocity is just how quickly it does that. And if we don't remember, that is represented, the angular velocity is represented as omega. A little kind of curly or curvy W. This is going to be the new one for us, acceleration. Linear acceleration we've dealt with before. Angular acceleration, or how quickly something speeds up its rotation or slows down its rotation, that's going to be represented as alpha. Okay, so alpha. Or if you want to draw this, we draw it like a little fishy. Alpha. Okay. Now, converting back and forth between these, we have these equations for our translational and Angular. Notice these are the exact same equation, just rearranged a little bit. So if I want to know the linear position, that's the radius of whatever circular thing I'm talking about times the angular displacement. Right? If I want to know angular displacement, I would divide both sides by r. Right? And that's how we get that equation right there. And all of these different equations right here, we've used these first two rows right here. The new one is going to be for us acceleration. And acceleration, just like before, the circular or rotational variable is the one that always has the radius attached to it. So radius times angular acceleration, radius times angular velocity, radius times angular displacement, so on and so forth. Okay? So let's get to some examples. The examples in your skill for Khan Academy have to do with proportional reasoning. And what those are going to look like is something like this. We have a giant wheel in an amusement park rotates with an angular acceleration alpha. And a point on its edge has tangential acceleration a. So here is the equation. This came from that little table that we used earlier. All right, a toy wheel rotates with angular acceleration 30 alpha. So let's do this, a giant wheel. So I'm going to say, and here, notice in the question, how does the radius of the giant wheel, r giant, compare with the radius of the toy wheel? So we're being asked to compare radii. So let's solve this equation for radius. Let's just rearrange a little bit. So I'm going to get r all along. I'm going to divide both sides by alpha. And I'm going to get radius is equal to a over alpha. Okay, so now let's go over and take a look at what we got. We got the giant wheel. Radius of the giant wheel is equal to, it said there's angular acceleration alpha. So that's just alpha in the bottom. And tangential acceleration a. So that's just regular old a on top. Good? Now let's look at the toy wheel. So radius of the toy is equal to angular acceleration 30 alpha. So now on the bottom where alpha was, I'm going to put 30 alpha. And the tangential acceleration is 7a. Now, one thing you can kind of notice, this a over alpha right there, that is this term, right? So let's substitute that term in, and we can get 7 over 30 radius of the giant one, right? So now I know, just kind of, let's rewrite this a little bit. Radius of the toy is equal to 7 over 30 radius of the giant. Okay, so the question asked us, how does the radius of the giant wheel compare? So I want my answer to say r giant equals. I want that to show what it compares with. This says r toy equals. So let's isolate this radius of the giant wheel. To do that, I'm going to multiply by the reciprocal right here, 30 over 7 on both sides. Right, these cancel out. And so I would be left with this. Radius of the giant wheel is equal to 30 over 7, the radius of the toy. That is how it compares. The radius of the giant wheel is 30 over 7 times bigger than the radius of the toy wheel. And that would be whatever answer, you know, these are usually multiple choice. So that would be whatever answer I'm looking for. Okay. All of these problems are going to have really similar processes. We're just going to be solving for different variables. So let's take a look at the next one. Let me get this more towards the top. There we go. Our red wheel speeds up. So speeds up right there is making me think alpha. With tangential acceleration a at distance r from its center. A blue wheel has these new terms right there. Right? How does the angular acceleration, so that's what we're being asked to solve for, angular acceleration. So let's rearrange this equation right here for the angular acceleration. And I would divide both sides by r, so that's a over r. Cool. So now let's do the red wheel. So alpha for the red wheel is a over r. Easy enough. The blue wheel is equal to tangential acceleration of 2a. So now I have 2a on top over the radius is 4r. And just like before, we can kind of see this a over r right there. Right, we can substitute that in, and we can now see that alpha of the blue is equal to 2 over 4, or 1/2. This becomes alpha of the red. But again, take a look, and this was, it wanted us to solve for alpha of the red. That's what it wanted us to compare. So I would now get alpha red all alone. I would multiply both sides by this reciprocal right there. Right, these cancel, and I would be left with alpha red is equal to 2 times or double alpha blue. And that's my answer that I'm looking for. All right, one more. The other variable it could ask us to solve for, a, acceleration. This is already asking me for, or this equation already says a equals. So I don't need to rearrange this at all. So now let's just kind of go in and plug in what we got. A large catapult throws a pumpkin that's r meters with an angular acceleration a. So a large is equal to r times alpha. Okay. A smaller catapult throws a pumpkin, so a small. It has angular acceleration 2 alpha, sorry, and radius r over 2. So r over 2, and this is 2 alpha. Well, if we simplify this out just a little bit, this is 1/2 r times 2 alpha. So 1/2 times 2, well, this just becomes r alpha, which was the exact same thing as our a large right there. Right, so you can kind of see we can substitute that in. So what we get is a small is equal to a large. And so they are, in fact, the same thing. There's no like rearranging that we have to do or anything like that. They are equal to each other. So how do they compare? They are the same. All right. That process should take us through for pretty much all of that skill. And with that, ladies and gentlemen, go ahead and take your first attempt at the first skill in the Khan Academy stuff. Let's see. We're going this first skill right here. Give it a shot, and I will see you all later.